So question 12, again, working with inequalities. Show the solution of each inequality on the number line and by using symbolic and interval notation. So this one's got a lot going on here. So let me pause for a second. So let's add a few extra notes here to this one. So there's a lot going on in this question. One of the things is this is what's called a compound inequality. So notice how the variables between two boundaries. So this kind of tells me we got two boundaries going on here. So one of the easiest ways to do this is rewrite this as two separate inequalities. So starting with the middle, we have negative. So we have the opposite of x, or negative x plus 2. And notice how we got to keep the inequality symbol going in the right direction. So it's actually greater than or equal to -7. And we also use this word and because this means you have to keep both things true. And then we have the negative x plus 2, then it's actually less than or equal to this -9. So when we solve these inequalities, one of the things we have to pick up on is this one's a little bit different because the coefficient in front of x is actually a negative. So in working with inequalities, if I multiply or divide both sides by a negative, the inequality symbol must switch as well to keep the truth. So this is important to us in this problem here, is to make this coefficient a +1, I'm going to have to divide both sides by a negative, and that's going to cause an impact with this inequality symbol that we have to pay attention to. So as I solve this inequality, I'm going to subtract 2 on both sides, or add a -2 to both sides, if you will. And then this becomes then the opposite of x is greater than or equal to a -9. Now, for some people, it's not a bad idea to make this a -1. So to get rid of a -1, you have to divide both sides by a -1. So when I execute this step here, the coefficient is going to turn into a 1. So this is going to become an x. But this inequality symbol has to reverse. It has to switch directions. So this becomes a less than or equal to. And then a -9 divided by a -1 becomes a +9. So then we bring down the word and. Then if we do this one over here, again, we have to subtract 2 to both sides, or add a -2 to both sides. This gives us a -x is less than or equal to a -11. But remember, this is a -1 in front here. The coefficient has to be a +1. So when I divide both sides by -1, we have to pay attention that that's going to affect the inequality symbol as well. So this turns into x, but this inequality symbol has to change directions. Greater than or equal to, and then that's going to turn into a +11. So if we write this out, our x, notice how 9 is our left boundary, 11 is our right boundary, and notice how x has to be, let's see here. So what this is saying is x has to be less than or equal to a 9, but at the same time, it's got to be greater than or equal to an 11. This sounds a little weird. So if I put this up on the graph, if I put the 9 and the 11 on the graph up here, less than or equal to 9 means you have to be over here. And you have to be greater than or equal to 11 over here. So is it possible to be less than -9, less than 9 and greater than 11 at the same time? So this kind of tells me that this is strange. So this is telling me that this is a no solution. It's not possible to be both of those at the same time. So this is a no solution in this problem. So there is really nothing to graph on the number line. So from a number line perspective, the number line would remain empty. You can't graph it. So there's nothing to graph because there's no solution. So the number line would remain empty on this problem. So there is no inequality to write because there is no solution. There is no interval that works for this as well. So this is just a flat out no solution answer.